Hello learners, and welcome to today's lesson of quadratic number patterns, arithmetic and geometric sequences. Let's get to our lesson. So in today's topic, we know that when it comes to quadratic number patterns, arithmetic and geometric sequences, these are the topics that are under it. And today we are going to focus on all of them. So by the end of this lesson, we will address identifying quadratic number patterns, arithmetic sequences, and geometric sequences, finding the general terms of the number patterns and sequences, and also working with unknown values in sequences. So we know that when we are working with number patterns and sequences, these are the terms or keywords that you are familiar with. Of course, these are the words that you keep on using and you know what they mean. So let's look at the common errors or misconceptions when it comes to this concept. So the learners do not use the correct formulas even though the formulas are provided. Now remember, in an exam, the formula sheet is provided. Make use of that formula sheet because the formulas are provided on that sheet. And again, learners do not know how to identify the correct formulas to use. So be careful that even though the formulas are provided for you, you need to choose the correct formula. Let's see what you should know or be able to do from grade 10 and grade 11. That is, you should know that n represents the number of terms in a sequence. A in an arithmetic sequence represents the first term of a sequence. D represents the common difference between terms. The general term of an arithmetic sequence is defined by Tn is equals to A plus open bracket n minus 1 close bracket, and that is multiplied by D. The general term of a quadratic number pattern is defined by Tn is equals to an squared plus bn plus c. Now the quadratic number pattern has a second difference. Of course, that is what you should know. Now, looking at the skills that you need for an exam, remember, you need to keep on practicing these skills so that you can successfully answer that exam. Let's quickly go to an ad break and then we'll see you just now for the rest of our lesson. Welcome back from the ad break, and let's continue with our lesson. So now we are going to go into that first concept of our concept map, and that is the arithmetic sequence. So let's look at the content and skill problem when it comes to this arithmetic sequence. Well, learners do not use the correct formula even though the formula is provided. So remember, you need to look at the formula sheet just to make sure that you get that correct formula. Now, when it comes to the exam, learners, again, do not use the formula sheet provided. So again, I cannot stress this enough. The formula sheet is there. Use it. You are used to working with these formulas, and sometimes it's very easy to think that we know them. But remember, during an exam, we are very stressed, so just use the formula sheet to make sure we avoid those small problems. So when it comes to the key aspects, so these are things that you've learned from grade 10. We know that the general term of an arithmetic sequence is Tn is equals to A plus n minus 1, and that n minus 1 is multiplied by D. And of course, we know that to find the common difference, that is calculated by D is equals to T2 minus T1, which is of course equals to a T3 minus a T2. Let's look at an example and put this knowledge to practical use. So the first example there says, given the sequence 4, 10, and 16, we are going to answer these questions. But now remember, the first thing we need to do is to find the rule between the terms. That is, we need to find that what is happening between the terms. How do we move from the first term to the second term? Now, when we are looking at this sequence, we can see that from 4 to 10, we can see that we did add a 6. And of course, we can simplify that by saying our T2 minus our T1. Remember, the difference can be obtained by saying T2 minus T1, that would be a 10 minus 4, giving us, of course, that 6. And just to make sure that this difference is common, so it needs to be common for us to conclude that this is an arithmetic sequence, we are just going to again calculate there T3 minus a T2. That is, of course, 16 minus 10. And again, that gives us an answer of 6. It means moving from 10 to 16, we can see that we added a 6. Now that 6 is our common difference. So it says there, determine the formula for the nth term. Now we are going to look at our formula sheet, and we know that the nth term is defined by Tn, but now make sure you use the correct Tn. Remember here we are working with a common difference, which is represented by a D. So when you look at the formula sheet, make sure that the one that you choose has a D in it to represent the common difference. And of course, we are looking for the nth term, so we are working with Tn. So you will see that that is a plus n minus 1, and that is multiplied by D. Now, when we substitute this Tn, we know that A represents that first term, so that is 4, and we are going to add this to an n minus 1. Remember, we are trying to find the nth term, meaning we do not have the value for n. So we are not going to substitute that n. We are going to substitute that D, which of course in this case is our 6. And then we know that when we simplify or we multiply that common difference into that bracket, we will have 4 plus 6n minus 6. Remember that 6 is going to be negative because it is going to multiply with that negative 1. And of course, as our final answer, we are going to have Tn is equals to 6n, and that is going to be a minus 2. And that's going to be our Tn. Let's look at the next question that says, calculate the 50th term. So now that we have our Tn, we know that our Tn is equals to 6n minus 2, as we've just calculated. And now we are being asked to calculate the 50th term. That is term 50. So now we know that we are given the value for n because n represents the term numbers. So that means that we are going to substitute 50 in the place of n. And of course, when we say 6 multiplied by 50, that gives us 300. And when we minus 2 from that, that gives us 298. Now, looking at the third question there, it says which term of the sequence is equals to 310. Now, mostly we confuse these two questions. When we are asked for the 50th term or we are asked which term, we don't know how to differentiate those two questions. But now remember, when you are asked for the 50th term, they are giving you the term number, meaning they are giving you the value of n. But as soon as a question asks which term, that means we do not have the value of n, and that is what we are going to calculate. So when we are asked which term of the sequence is equals to 310, then we know that that 310 is our Tn, that is our answer, and we are just trying to find which term was it in the sequence. So we are going to write down our formula. Tn is equals to 6n minus 2. And then in the place of Tn, we have 310. That is going to be 6n minus 2. Of course, that's going to give us 6n. We know that if we take the 2 to the other side, that is going to be 312. That is 6n, 312 on this side. And if we divide both sides by 6, we know that our answer or our value for n, that is going to be a 52. So 52 is going to be our answer. Let's move over to a different question when we have been asked to calculate unknown values, or when our arithmetic sequence has an unknown or a variable in it. Given the arithmetic sequence 1 minus p and 2p minus 3 and p plus 5. So we can see that 1 minus p is our first term, 2p minus 3 is our second term, and p plus 5 is our third term. Now the difference between this question and the previous question did not tell us whether it's an arithmetic or a geometric or a quadratic. We had to find that ourselves by finding the rule between those terms. But now we are told that this is an arithmetic sequence, and that means a lot to us, because now with the first question that says determine the value of p, you need to recall the things that you know about an arithmetic sequence. And that is that with an arithmetic sequence, we do have a common difference, and that is represented or calculated by saying T2 minus T1. And that is exactly what we are going to do here. We know that it's an arithmetic sequence, meaning that first difference is common. So we are going to take our second term and we are going to minus our first term. So that means we are going to take 2p and we are going to say, okay, that's 2p minus 3, that is our second term, and we are going to subtract our first term, and that is 1 minus p. And please do not forget to use those brackets, they are very important. Then again, we are going to take our third term, and that is our p plus 5, and that is going to subtract our 2p minus 3. So all we've done there was to simply just say T3 minus T2, and that is equals to T2 minus T1. And that is what we are going to use to find the value of P. So let's go ahead and write these down. So that is T3 minus T2, and that will be equals to T3 minus T2, and that will be equals to T2 minus T1. Of course, we saw there that our T3, that is p plus 5, and that is going to subtract with 2p. And of course, we have used our brackets there. That negative is going to multiply with the 2p. That negative is going to multiply with the negative 3 as well, giving us a positive 3. And that is going to be equals to, we have there our T2, which is 2p minus 3. And of course, that is going to be minus 1 and a plus p. Remember, it is a plus p because of that negative that multiplied with both the terms in our first term. Then all we need to do is to put the like terms together, and then we are going to find the value of p. So when we say p minus 2p, that's going to give us a negative p, and 5 plus 3 is going to be an 8. And that, of course, is going to be equals to 2p plus p, that is 3p, and a negative 3 minus 1, that is a negative 4. When we put the like terms together, we are going to have a negative 4p on one side, and on the other side, we're going to have a negative 12. We're going to divide both sides by a negative 4, and the value for our p is going to be a positive 3. That is the value of p. Looking at that last question there, it says determine the values of the first 3 terms. Now remember, we did have the first 3 terms, but they were in terms of p. So now we need the actual values of the first 3 terms. So we know that our first term was 1 minus p. And since as well we have the value of p, that means it's 1 minus 3. And of course, that gives us a negative 2. When it comes to the second term was a 2p minus 3, and that is going to be a 2 multiplied by the value of p, which is 3, and that is minus a 3. And of course, that is going to give us an answer of 3. And when it comes to the third term, that is going to be, the third term there is a p plus 5. That of course is going to be a 3 plus 5, which is going to give us an 8. So the first 3 terms of this sequence is negative 2 for the first term, 3 for the second term, and 8 for that third term. Let's quickly go to an ad break, and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. So now we are going to go over to the geometric sequences. Let's see what we have. So firstly, when it comes to the content and skill problems, we know that learners do not use the correct formulas even though the formulas are provided. So remember, use that formula sheet. And again, learners confuse calculating the common difference and the common Learners confuse calculating the common difference and the common ratio. So usually there is a confusion between those two. And then when it comes to the exams, learners do not use the formula sheet provided. So please, please, please use that formula. But again, when you do use that formula, remember to choose the correct formula, because another problem in the exam is that learners choose the wrong formula. Let's look at the key aspects that you learned from grade 10 right up until grade 12. So we know that the general term of a geometric sequence is Tn is equals to a multiplied by r exponent n minus 1. And for us to calculate the common ratio, that is calculated by saying r is equals to T2 divided by T1 and T3 divided by T2. So immediately we can see that difference between an arithmetic sequence and a geometric sequence, because when we are subtracting to get the common difference, then that will be the arithmetic because we are finding the common difference. But now when we are dividing, we divide to get the common ratio, and that tells us that that is a geometric sequence. Let's look at the first example. It says there, if 5x 45 are the first three terms of a geometric sequence, determine the value of x. So we know that 5 is our term 1, x is our term 2, and 45 is our term 3. So those are the first three terms. Now, how are we going to find the value of x? Well, we know that this is a geometric sequence because the statement tells us that this is a geometric sequence, which means that these terms have a common ratio. So how do we find the common ratio? Well, we are going to say there that we're going to take T2 and divide it by T1, which is 5. So T2, which is x, and we have divided it by T1, which is 5. And of course, this will be equals to T3 divided by T2. That is going to be our 45. And that is going to be divided by x. So we are going to work with this as our equation. We are going to say x divided by 5 is equals to 45 divided by x. And we know that if we want to get rid of a denominator, we can just multiply by the denominator on both sides. That is going to give us x squared. And that will be equals to a 225. That's, of course, if we say 45 multiplied by 5. So how do we get to the value of x? We know that we are going to square root both sides, and that is going to give us x. But remember, when we introduce a square root, there's a possibility of it being positive or a negative, which means that our answer will be a positive or a negative 15. And that is the value of x. So that is how you calculate when you are given variables in the sequence, but as long as you are told which kind of sequence it is, then that should make things easy for you, because you would know how to calculate either the common difference or the common ratio. Let's move over to our second example. So the second example there says, in a geometric sequence, the fifth term is 80 and the common difference is negative 2. So now we have been given here the fifth term and the common difference. So that means we have been given term 5. And as we know, or maybe let's start by writing the general term for a geometric sequence, and that is a multiplied by r to the exponent of n minus 1. But we have been given term 5 here, which means there is something that we know, and that is the value of n. So we know that a multiplied by r, and that will be 5 minus 1. But again, we are told that that fifth term is 80. So in the place of T5, we can just go and substitute that value there. Now, when we look further into the statement, it also gave us the common ratio, and that common ratio is -2. So we can go ahead and substitute that common ratio as well of -2. And of course, when it comes to the exponent there, we can see it's 5 minus 1, which gives us that 4. So how are we going to solve for that? Well, firstly, we are going to start with the exponents, and that is going to be that -2, and that is to the exponent of 4. We know that that is going to give us 16, a positive 16 that is, and when we divide both sides by that 16, we can see that our A is equals to a 5, and that is the value of A. Remember, you need to use the correct formula, and you can simply do that by going to find that formula on the formula sheet. Let's move over to the last concept of our concept map, and that is the quadratic number patterns. So when it comes to the content and skill problems, when it comes to the quadratic number patterns, is that learners do not know how to find the general term. And again, learners fail to associate the quadratic number pattern with a quadratic function. Now, if you remember our quadratic functions, that is the parabola. So you need to realize that this quadratic number pattern is actually giving us a quadratic function. So we need to make sure that we have this connection in mind when it comes to those questions. So when it comes to the exam, again, learners fail to show how an equation was obtained. So usually this is in a case where the equation is given to us and we need to show how that equation was obtained. Let's get to that first question. It says there, the first term of a geometric sequence is 14 and the sixth term is 448. Calculate the value of the constant ratio. Now remember, we are being told that this is a geometric sequence, and we are going to use that knowledge to find the constant ratio. Now, what do we know about a geometric sequence? Well, we know that the general term is Tn is equals to A multiplied by R exponent n minus 1. So that is what we are going to focus on there. So we are told that the first term of that geometric sequence is 14. So we know that T1 is equals to 14. But of course, we should know by now that T1 is also the value of A. So us now knowing that, we are going to use that to find that constant ratio. So we are also told that the sixth term is 448. So T6 is equals to 448, and that is what we are going to use this statement. We are going to use that statement to find the value of R. So now, using that 448, we know that that is the sixth term. So if I substitute it in the general term, that is going to be A multiplied by R, and of course in the place of n, we are going to have a 6 minus 1. But we already do have the value of A, and that is 14. So that means that we are going to have 14 multiplied by R, and that is going to be to the exponent of 5. So we are going to divide both sides by 14, and we are going to get an answer of 32. Of course, that's 448 divided by 14. On this side, on the left-hand side, we're going to have R exponent of 5. And if we calculate that, we know that 32 is 2 exponent 5, and because the exponents are the same, that means the bases are equal, since as well these two powers are equal to each other. So therefore, that means that our R is equals to 2. You need to always remember those exponential laws, especially when you are working with geometric. But of course, there was another way of calculating it, and that is to root it with a 5. Let's move on to the next question. So it says there, it is given that a general term of a quadratic number pattern is Tn is equals to n squared plus bn plus c. And the first term of the first differences is 7. Now, we need to look at the information that is given to us. Firstly, we are told that this is a quadratic. So we know that a quadratic number pattern, the general term is an squared plus bn plus c. So immediately from this calculation, we know that a is equals to 1 because we can see that it is given there. We also know that c is equals to 9 because it is also given there. And we are also told that the first term of the first differences is 7. That means that that 7 is equals to t2 minus t1. That is the first term of the first differences. And that's the value that we get when we say t2 minus t1. So our question there then says to us, show that b is equals to 4. So we are going to use this information to show that b is equals to 4 because as we can see, b is the only value that was not given to us. Now, if we remember correctly, we know that to calculate b, we need to say 3a plus b is equals to t2 minus t1. Now, we already have our a, which is 1, and of course, we already have our t2 minus t1, which is 7. Then this would mean that b is equals to a 4. Sorry for that. So b is equals to 4, and there we've shown that our b is equals to 4 just by using the knowledge that we have of quadratic number patterns. Then the next question there says, determine the value of the 60th term. So we are working with that quadratic number pattern, but now we have the full number pattern, which is, or the full formula, general term, that is n squared plus 4n plus 9. So you have calculated the value of b, it is 4. So please, moving forward, you must use that value. But if anything happens in the exam and you find that you could not find the value of b, you now have the value of b. That means you can continue to answer the other questions as well. So we are going to substitute 60 in the place of n, since as well we are looking for the 60th term, meaning the n is given to us. The term number is given to us. So that is 60 squared plus 4, and that 4 is going to be multiplied by 60, and we are going to add 9, and then we are going to have an answer of, that is the 60th term, that will be equals to 3,849, and that is the 60th term. Then, still working with the same sequence, it says there, determine the general term for the sequence of the first differences. So they are not looking for the general term of the quadratic number pattern, but they are looking for the general term of the sequence of the first differences. So as you know, when it comes to a quadratic number pattern, the first differences also form a sequence on their own. So it says, determine the general term for the sequence of the first differences of the quadratic pattern. Write your answer in the form TP is equals to MP plus Q. So those unknown values or those variables that we are not used to, they should not intimidate you. But we do know that we are not going to calculate Tn, we are going to be calculating Tp. And the reason why we are using a different letter here is because we already have Tn. Remember, our Tn is n squared plus 4n plus 9. So now we need to find TP, which is going to be, of course, the arithmetic number pattern. Now, we know that when it comes to an arithmetic, that general term is, and remember, we are told to use P and not N, because N has already been used. That means that that is going to be A plus, that's P minus 1, and that is with the common difference of D. So all we have to do is to substitute so that we can get that general term. Now, our first term of this sequence is that 7. Remember, in the information that we were given, we were told that the first term of the first differences is 7. So definitely we are going to use that. But now, what is the difference of this sequence? What are we going to substitute in the place of D? Well, you have a choice of going to find this sequence here. So you can go and find the first three terms. And if you do find the first three terms, they will be 14, 21, 30. You can even make it the first four terms, and that is 41, just to get that sequence that you are familiar with. Now, if we find the difference, that is going to be 7, and this confirms the value that we were given in that statement. Then we are going to have 9, and we are going to have 11. And this is the sequence that we are focusing on. The first differences, they form a sequence for themselves, and that is an arithmetic sequence. How do we know that it's an arithmetic sequence? Because it has a common difference. So when we are just looking at the first differences, they have a common difference of 2, which is of course the second difference for the quadratic formula. So us knowing that this is the difference for the arithmetic sequence, then that is going to be the value that we substitute in the place of D. Of course, there was another way of finding that value of 2. Remember, we said we know that our value of A is equals to 1. Well, if you remember how to calculate the value of A, then you would know that that difference would be A2. So when we calculate that TP, that's going to be 7 plus 2P, and that is going to be minus 2. Do not confuse what you need to do when you are simplifying this expression. That is a common mistake. And then when we say 7 minus 2, of course, that's going to give us a positive 5. So the common difference, the common error there is that usually you just say 7 minus 2 and you say a negative 5. But we can see there that 7 minus 2 is a positive 5. Let's now go to a very commonly asked question. That's the next question there. It says, which two consecutive terms in the quadratic number pattern have a first difference of 157? So what are they asking here? They are saying that in a quadratic sequence, so somewhere along that quadratic sequence that we had, remember it was a 14, then we had a 21, and then we had a 30, and a 41. And as this sequence continues, we come across two terms that we now need to find what terms those are. But what we do know about these two terms is that the difference between them is 157. Now you will notice that this 157 is in the first differences. And remember, we do have a formula for those first differences. That formula that we found was 2p plus 5. Now we need to find what sequence or which term is equals to 157. And of course, we can do that by substituting in the place of TP 157. That's going to be 2p plus 5. That is going to be now 2p is going to be equals to 152. And when we divide both sides by 2, that is going to give us P is equals to 76. Now we know that P is equals to 76, which actually means that the term here, this term is term 76. So what does that mean for those two consecutive terms? Yes, that means that 156 will be between term 76 and term 77. So our answer there will be the two consecutive terms are term 76 and term 77. Let's quickly go to an ad break and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson. So the third question there says, consider the following sequence. We have 2 divided by 1, then we have a negative 1 divided by 5, and then we have a negative 4 divided by 25. Now, looking at this sequence, remember, when we are given a sequence, the first thing we're going to do is to try and subtract those terms. So that is T2 minus T1 or T3 minus T2. If the first difference is not the same, we're going to try and find a second difference. And if that doesn't work, our last option is a quadratic sequence, a geometric sequence. And that's where we are going to say T2 divided by T1. When it comes to the sequence that we have been given here, all of those will not work. So we will try to find what sort of pattern is going on in these. Now, if you look carefully, you will see that when you look at the top numbers of this sequence, they form a pattern on their own. So that is 2, -1, and -4. So you will see that they have a pattern on their own. What is that pattern? So we know that if we say T2 minus T1, that's -1 minus -2, that gives us a -3. And when we say -4 minus a -1, that also gives us a -3. What about the bottom pattern there, or the denominators? So this means that the numerators form a pattern. We've already seen that. What about the denominators? Well, the denominators also form a pattern, because we can see that we've got 1, 5, and 25. And of course, we know that that sequence will continue. What is the pattern there? Well, we can see that if we say T2 divided by T1, that is going to give us a 5. And again, if we say T3 divided by T2, that's also going to give us a 5. So with the denominators, we have a common ratio, and with the numerators, we have a common difference. So that means that the numerators form an arithmetic pattern and the denominators form a geometric pattern. Our question there says, write down the fourth term of this sequence. Now, when it comes to the numerators, we know that from -4, if we subtract if we add a -3, or if we subtract 3, that is going to give us a -7. And that is with the numerators. And of course, when we continue multiplying by 5 with the denominators, we can see that if we say 25 multiplied by 5, that is going to give us 125 as our answer. And that, of course, is the fourth term. What about determining a formula for the nth term? So we are talking about a geometric sequence. Well, we've already seen that the numerators are form an arithmetic number pattern. So that is a plus n minus 1 d, and of course that will be our general term. That is divided by a geometric sequence, which is a r exponent n minus 1. So that's a multiplied by r exponent n minus 1. Now, when we substitute these values here in the numerators, we can see that the first term is a 2, and that we are going to add to an n minus 1, and that is going to give us a -3 for the d. And then we have the first term of the geometric sequence, which is the denominators, and that is 1. That is multiplied by 5, and that 5 has an exponent n minus 1, which means that our general solution there will be a 5 minus 3n, or you can say -3n plus 5, and that of course will be divided by 5 exponent n minus 1, and that is the nth term. Arithmetic as the numerators and geometric as the denominators. Let's go over to the next question, where we are still working with the same sequence. And remember, for our Tn, and that is the nth term, we found that it is 5 minus 3n as the numerator and 5 exponent n minus 1 as the denominator. So it says that determine the 500th term of the sequence. Again, this means we have n because they are telling you that the value of n is 500. So they are not asking which term, but they are telling you that the 500th term is equals to, they are asking you to calculate, the 500th term. So they are giving you the value of n, which is 500. So we are going to use this general term that we have there, and that is our Tn is equals to 5 minus 3n divided by 5 exponent n minus 1. Now, when we substitute here, that's going to be 5 minus 3 multiplied by 500. And of course, that is going to be the 500th term. So you have to substitute everywhere. That is the term 500. That is going to be 5 minus 3 multiplied by 500. And of course, we are going to have a 5 exponent 500 minus 1. And what answer are we going to have here? Well, as the numerator, we are going to have a negative 1,495. And as the denominator, you can write it as 4 exponent 499. Because we know that if we say 5 exponent 499, it is going to be a very big number. But we can leave it in that state. Let's look at the next question. It says, which will be the first term of the sequence to have a numerator which is less than 59? So the question is focusing on the numerator, which means that's exactly what we are going to do. We are going to focus for the general term of the numerator. So we want to know that which is the first term. So which is the first term? We are being asked for n. So which is the first term to be less than negative 59? Well, do we know how we represent less than in mathematics? We just need to take these words and make them an equation. So we know that the general term for the numerator was 5 minus 3n, and we want to know what value of n is going to make the numerator less than negative 59. So we've taken that sentence and we've translated it into an equation. When we are calculating here, we are going to have a negative 3n. That's going to be less than a negative 64. We're going to divide both sides by a negative 3. And do you know what happens to an inequality when we divide by a negative value? Yes, the inequality will also change, just like all the values are going to change signs. So a negative does change the signs of the numbers. So this is going to be n is greater than 21,33, and that 3 recurs. So which is the first term that's going to make sure that our numerator is less than 59? Well, our answer says it's greater than 21,33, and the first natural number that is greater, or the first whole number that is greater than 21,33 will be 22. So our answer here is actually 22. Let's go over to the next question. It says there, the general term of a quadratic number pattern is Tn is equals to an squared plus bn plus c, and its first term is 8. The general term of the first differences of the pattern is Tk is equals to 4k minus 2. So it determined the next two terms of the quadratic pattern. So we know that the first term of this quadratic pattern is 8. And what we need to do is now find the next two terms. Now what we have here is the sequence for the first differences, which is 4k minus 2. Now if we substitute 1 in the value of k, that is going to give us a value of 2, which means that the first differences is 2. Again, if we substitute 2 in the value of k, then we know that that is going to give us a 6. How do we know this? Because we have been told that this is the general term of the first differences. So we are able to get those values there. That is going to help us to get the next terms of the quadratic number pattern. So if the difference between this value here and 8 is 2, then it means that that value is going to be a 10, because 10 minus 8 would give us a 2. The next value there, it means the difference between this value and 10 is 6, which simply means that this is going to be 16, because 16 minus 10 is equals to 6. So that is then the next two terms of that quadratic pattern. Moving over to the next question of the same question, we are then asked there. So it's the same question. It says, hence, show that the general term of the quadratic number pattern is given by Tn is equals to 2n squared minus 4n plus 10. Again, the question says show that the general term. So we already have the general term. We just need to show how they obtained that general term. So we already know that the first three terms of our sequence is 8 and 10 and 16. Of course, you can continue with that, but we do know that when it comes to the difference between these two, we did find 2 as that difference, and we had 6 here, which means that the difference between the 6 and the 2, that is our 4. Now remember, this is all we need to find that general term. Why? Because we know that our 2a will be equals to our second difference. We know that 3a plus b will be equals to our T2 minus our T1, and in this case, that is our 2. And of course, we know that A plus B plus C is going to be equals to the first term, and that is the 8 there. So we are going to just calculate the general term the way we know how to calculate the general term, and we just need to make sure that it is the same as what we were given. That's how we will know that we are correct. So we know that 2a is equals to 4. If we divide both sides by 2, that means a is equals to 2. And if we look at what we were given, a is equals to 2. So we know that we are moving in the right direction. Then we have 3a plus b is equals to T2 minus T1, that is equals to our 2 over there. So we already have the value for a, that is 2. And which would mean that our b is equals to 2 minus 6, which is a negative 4. Again, we look at the sequence that we were given, we can see that the value of b is a negative 4. So again, we are still moving in the right direction. So you always need to check to see if you're moving in the right direction. Then we have a plus b plus c, that is equals to the first term, which in this case is 8. That would be 2 in the place of a, plus negative 4 in the place of b, plus c, that is going to be equals to 8. And when we say c, we're going to say c is equals to 8 plus 2. When we work that out, that is going to be our 10. So from what we were given there, we can see that we have found the same general term there as we were asked to prove, and that is 2n squared plus minus 4n plus a 10. And that is what we were asked to prove. We have proved it, and that is the answer. Let's quickly go to an ad break, and then we'll see you just now. Welcome back from the ad break, and let's continue with our lesson where we are going to wrap up this wonderful lesson that we have just had. So remember, when we are talking about quadratic number patterns, arithmetic and geometric sequences, we did focus on those arithmetic sequences, the geometric sequences, and also the quadratic number patterns. Then do not forget those keywords that we keep on using when we are working with number patterns. And looking at those common errors or misconceptions, remember, you need to use the formula sheet. So you cannot get those formulas wrong, because wrong formulas means that you will get no marks. So please use the formulas that are provided, and most importantly, use the correct formulas. So even if you use the formulas from the formula sheet, you need to make sure that you've chosen the correct formula. Do not forget those exam writing skills that you need to have that will help you in the exam. And lastly, we know that we need to practice. So make sure that we practice when it comes to number patterns and sequences. And always remember to practice. So here are a few question papers that you can use to sharpen those mathematical skills. Thank you for joining us for this wonderful lesson. We hope to see you next time. Goodbye.